Okay, let's review how to name some ionic compounds. So you always take the cation, then you name the anion, and then you end in "ide." A cation is something with a positive charge. So let's say you have some calcium with a 2+ charge and some chlorine with a 1-. We all know it makes CaCl2. To name that, we would say calcium, and then chlorine, and chlorine becomes chloride. And that's its name. Let's try another one. Let's say we have some aluminum and some fluorine. Aluminum is 3+, fluorine is 1-, so it makes AlF3, and its name would be aluminum fluoride. Now the other way to name ionic compounds is using a Roman numeral. So let's say you have a cation with a varied charge. Iron is a perfect example of that. It's in the middle of the periodic table. Its charge can be 2+ or 3+. So you'll see iron, and let's say you have iron chloride. There's a 3 after that. The way we're going to name that is by say iron, and then we put a Roman numeral in the middle of it. And we get the Roman numeral from looking right here. This is the charge, the type of iron it is, if you will. And then it is chlorine, so chloride again. In comparison, let's say we have FeCl2. Now we have iron, Roman numeral 2, chloride. How did I know that? Because of this 2 here. Okay, let's try a few more with varied charges. And this is an interesting one because we have copper. We know it's a transition metal, so there's going to be a Roman numeral, and this is nitrate. And you kind of have to work backwards, and you have to think, hey, what's nitrate's charge? Some people might say that this is copper 3 nitrate, but that's not true. Because if we put parentheses around nitrate, you'll see there's only 1 nitrate. And so therefore, we work backwards. It's 1 nitrate, so therefore it's copper 1 nitrate. In comparison, let's say we have copper and some sulfate. And this one's a little interesting. Sorry, that copper looks a little funny, but because this is also copper and sulfate, and to get that Roman numeral, we kind of have to work backwards. But this is the toughest of the examples because you put the parentheses around and you're like, hey, there's only 1 sulfate. But actually, this is copper 2 sulfate. And this is because sulfate's charge is 2- when it's an ion. Therefore, we must have 2+ here to make them equal and opposite. Let me show you, kind of work backwards. So this is what we're starting with. And then you crisscross them so that they're equal and opposite charges make this. So this is this name. And that's probably the most confusing example of all the examples. Let's look at one more for copper. Let's say we're at copper and there's a 2 after the copper, and then we have the sulfate here. Now this is an interesting example because you might be thinking, oh, it's copper 2 sulfate again. No, this one's actually copper 1 sulfate. Remember, we're doing this Roman numeral thing because the charges can vary. And the way you would work backwards on this is this 2 goes up here, and there's no 1 here. There's not another number besides 1, so this would be 1-. Sorry, 1+. So anyways, the work backwards, let me start from this side. Maybe you can see it better. This is what we were starting with, and this is what I gave you as the example. And then the name is here.